I'm Tori Clifton, and I'm here to give you the rundown on calorimetry. Calorimetry is the measuring of the change in heat associated with reaction. We do this by measuring the change in temperature of reactions surrounding, which will in turn tell us about the system. Before we get to specifics, let's talk about what a calorimeter looks like. It can be any insulated container with a thermometer to measure a change in temperature. It needs to be insulated so there is no outside source that it can affect the temperature change we are measuring. Think about it like wearing 2 coats in the winter and how that keeps your body heat closer to you so you stay toasty. There's also usually a stir bar to ensure that the reaction is being done to completion. Now let's get into the specifics behind the science of calorimetry. Since it's measuring the heat change of a system, we can use the equation of delta H equals Q. And since we know it's at a constant atmospheric pressure, we know that Q equals MCAT. That's how I remember it. MCAT stands for mass times specific heat capacity times change in temperature. Specific heat capacity is the heat change when 1 mole of a substance is formed from its elements. This can be looked up because some very nice chemists have already found all of those out for you. Another important thing to know is that a reaction can be exothermic or endothermic. Exothermic means that the system is giving off energy, therefore the surroundings temperature will be increasing in the calorimeter. Endothermic means that the system is taking in energy, meaning that the surroundings temperature will be decreasing in the experiment. One tip to remember to make your experiment run smoothly is that you should be measuring temperature in Celsius or Kelvin. This is because they have the same increment of temperature change represented by 1 degree. Some possible uses for calorimetry is helping us to understand how drugs will react in your body and what fuels will be most effective by measuring how much heat energy they give off as a system. I hope this has been helpful, and I can't wait to see what amazing thing calorimetry helps chemists come up with next.